Welcome to this explainer. Today we're unpacking the absolutely cutthroat history and the fascinating thermodynamics of exactly how humanity learned to control the cold. I mean, it's a wild story, right? Full of ruthless monopolies, microscopic thermal motion, and brilliant inventions that quite literally reshaped our modern world. So let's dive right into a pretty terrifying reality. Picture this. It's the sweltering summer of 1841 in Florida, and Dr. John Gorrie is absolutely desperate. Yellow fever, which grimly enough was also known as the black vomit, is wiping out entire families. His patients are severely jaundiced, burning up with fevers hitting 40 degrees Celsius, and Gorrie knows that simply cooling them down offers a vital, maybe life-saving relief. But getting ice? Practically impossible. The tragic reality was that the only way to get it was through a single, cutthroat global monopoly. A few days' supply would have cost a normal person more than their entire yearly wage. They didn't call it white gold for nothing. To really understand how we democratize the cold, our roadmap today will take us through 6 key chapters. First, the Ice King's monopoly, then ancient secrets of ice, followed by the quest for artificial ice. After that, we'll hit the natural ice crisis, the cold chain revolution, and wrap up with chilling the modern world. Chapter 1, The Ice King's Monopoly. Our story kicks off with a 22-year-old Boston merchant who somehow managed to turn frozen water into an absolute empire. His name was Frederic Tudor, and his relentless drive, well, it actually started with a tragedy. His brother died of a severe fever while they were traveling in the Caribbean, and Tudor convinced himself that if they just had ice on the islands, his brother would have survived. Back in 1805, people literally laughed in Tudor's face for wanting to ship ice to the West Indies. I mean, it sounds crazy, right? And honestly, early on, it was. In 1806, his first shipment to Martinique was a total disaster. His team somehow forgot to build an ice house, and he made a measly $50 before his entire cargo just melted away on the docks. Fast forward to 1809, he's over $1 million in debt in today's money, dodging sheriffs, and actually gets thrown into debtor's prison. But the guy just refused to quit. Finally, by 1833, he pulls off the impossible, a successful 4-month shipment halfway across the globe to Calcutta, India. To put his success into perspective, by 1856, Tudor's empire was moving a staggering 132,000 tons of ice in a single year. He took what used to be a super rare luxury strictly for wealthy landowners and transformed it into an everyday commodity. That earned him the very fitting title of the Ice King, and he earned that crown ruthlessly crushing any copycat competitors to keep his iron grip on the global supply. Chapter 2, Ancient Secrets of Ice. Now this obviously raises a huge question. How on earth did Tudor keep ice from melting on a weeks-long journey through the blazing Caribbean sun or a months-long trip to India? Well, it all comes down to the square cube law. Think about it. If you have a bunch of small, separated ice cubes, they melt incredibly quickly because there's a ton of surface area exposed to the warm air. But if you pack them all tightly together into one massive megacube, the ice survives so much longer. Actually, a giant sphere, like a mathematically perfect snowman, is best because it minimizes the surface area exposed to heat conduction. Basically, as you scale up the volume of the ice, the surface area just doesn't increase at the same rate. Now, Tudor definitely didn't invent these principles. He essentially bet his entire fortune on ancient Persian techniques dating back to 500 BC. Ancient kings like Xerxes used to enjoy summer ice, thanks to Yakhchals, these massive domed ice houses. The method was brilliant. Freeze water in shallow pools overnight, pack that ice tightly into deep pits where cold air naturally sinks, funnel the warm air out, and seal the whole thing up perfectly. Tudor just adapted this for his ships. He elevated the ice above the meltwater and packed it with free sawdust from Boston's sawmills for insulation. And get this, to build up his market, he gave bartenders free ice, knowing it would completely hook their customers on cold drinks. It was a genius marketing trick that popularized ice cream in places like Cuba. Fun fact, that specific legacy is what led to Fidel Castro's infamous 18-scoop-a-day ice cream obsession, and eventually a spectacularly failed CIA plot to assassinate him with a poisoned milkshake. No way, right? Meanwhile, back in America, ice was becoming completely ubiquitous. Wooden ice boxes were popping up in ordinary kitchens everywhere, which gave birth to a brand new profession, the Iceman. These guys were lugging massive 45-kilogram blocks of ice directly into people's homes. Because they were one of the very few deliverymen actually invited inside the house, the Iceman became this huge cultural phenomenon. It got to the point where the Iceman was the punchline of endless cheesy 19th century jokes, even featured on vintage Valentines, along with songs and rumors. That brings us to Chapter 3, The Quest for Artificial Ice. Because while the Ice King was getting rich, Dr. John Gorrie was still down in the sweltering heat of Florida, desperately fighting those deadly yellow fevers. He realized the only way to save his patients and completely break Tudor's monopoly was to invent a way to manufacture cold artificially. And Gorrie actually pulled us a brilliant thermodynamic breakthrough. He figured out that compressing air with a piston actually increases its temperature simply because you're adding energy to the air molecules. But, and here's the genius part, if you take that hot, high-pressure air and cool it down in a water bath, it drops back to ambient temperature while staying highly pressurized. Then when you let that air rapidly expand, its temperature absolutely plummets, dropping way below freezing. Gorrie used this super chilled air to cool a tank of salt water, which won't freeze at 0 degrees, and then submerged metal molds of fresh water inside it. Boom! He essentially created the world's very first ice cube tray, proving once and for all that humanity could make its own ice. Chapter 4: The Natural Ice Crisis. Of course, the Ice King wasn't just going to sit back and let a rural doctor ruin his empire. Tudor struck back hard. He paid off newspaper editors all up and down the eastern seaboard to smear Gorrie as a total crank who was trying to play God. And sadly, the smear campaign worked. Gorrie ended up dying alone and penniless. But natural ice was hiding a deadly secret, one that would soon completely vindicate Gorrie's vision. You see, Gorrie had faced this intense public stigma. Back then, the public firmly believed in God-made natural ice, and they viewed machine-made ice as godless and unnatural. And that deep-seated bias stuck around right up until the peak of the Industrial Revolution, which is when humanity fundamentally altered the environment and severely polluted the exact same lakes where all this natural ice was being harvested. So suddenly, this supposedly pure, God-made natural ice became incredibly lethal. Factories and farms were dumping chemicals, farm detritus, and rotting animal matter straight into the rivers. And all those contaminants froze right into the ice blocks. Imagine putting a chunk of that ice into your cocktail or using it to treat an open wound in a hospital. It could literally give you cholera or severe food poisoning. This terrifying public health crisis finally forced society to ditch natural ice and embrace the clean, sterile, machine-made ice that Gorrie had pioneered years earlier. Moving into Chapter 5, the cold chain revolution. This massive shift to reliable artificial ice did so much more than just clean up our drinks. It unleashed an entirely new system of logistics, what we call the cold chain, and that fundamentally redesigned the entire geography of American cities. Before the cold chain, cities were absolutely packed with dirty, noisy livestock, simply because meat had to be slaughtered locally before it spoiled. But the invention of rail cars insulated with ice changed everything. The impact was explosive. Slaughterhouses could now stay out in the Midwest, which caused Chicago's population to skyrocket from 30,000 to 1.7 million in just 50 years. Meanwhile, New York City was finally able to clear the cows out of its urban center, freeing up massive amounts of land for housing and factories, all while its beef shipments jumped 25-fold in just 4 years. Oh, and fun fact, this new refrigerated rail system is the exact reason why a certain crunchy, water-filled vegetable being shipped across the country became famously known as iceberg lettuce. Chapter 6: Chilling the Modern World. So the refrigeration boom was well underway, but it kicked into absolute overdrive when a Scottish-born engineer in Australia named James Harrison decided to improve on Gorrie's original air compressor design. Harrison made this massive leap forward by harnessing fluid dynamics, specifically a process called phase change. Think about a can of freeze spray. When the liquid shoots out and turns into a gas, it has to absorb a massive amount of heat energy from its surroundings to break that molecular attraction that instantly freezes whatever it touches. Harrison built a closed loop that continuously evaporated and condensed a liquid, utilizing this phase change to aggressively absorb heat. It was wildly efficient. He was able to manufacture a staggering 3,000 kilograms of ice a day. And here's the crazy part. That exact same phase change loop is the underlying technology powering the fridge sitting in your kitchen right now. By 1927, affordable home refrigerators finally hit the mass market, and the adoption rate was just phenomenal. We went from less than 1% of American homes having a fridge in 1920 to an unbelievable 85% by 1944. That adoption was actually faster than the motor car replacing the horse-drawn cart. So why does all of this actually matter today? I mean, it's really easy to take your refrigerator for granted, thinking it's just there to keep your strawberries fresh or chill some leftover pizza. But the exact same principles that were used to ship 19th century beef form the absolute backbone of modern science. Think about it. Blood donations, insulin, life-saving vaccines, they all rely entirely on the cold chain. But it goes even deeper than that. But using these exact thermodynamic principles to cool things down to almost absolute zero, we can operate MRI machines, we can smash particles at the Large Hadron Collider, and we can peer deep into the universe with the James Webb Space Telescope. Heck, even the bacteria enzyme that makes PCR testing possible was only discovered after it sat safely preserved in a refrigerator for 16 years. As we wrap up this explainer, I really want to leave you with this thought. For almost all of human history, from the very discovery of fire onward, we only knew how to speed up molecules and create heat. The true miracle of refrigeration wasn't just cooling down our summer drinks. It was finally figuring out how to remove thermal energy, literally slowing molecules down on a microscopic scale. We mastered the cold, and in doing so, we completely reshaped our cities, revolutionized our medicine, and expanded our understanding of the universe. So what further boundaries do you think humanity can push by controlling this invisible thermal motion? Thanks so much for joining me on this explainer, and keep asking the big questions.